Hi everyone, welcome back to my YouTube channel. I am Riti and I'm back with another lecture in the DBMS series. So in the last lecture we learned about schedule and types of schedule. In this particular video we would be learning about serializability. So without any further ado, let's get started. Now if you remember in the schedule lecture we learned about serial as well as concurrent schedule. Now what are these? So in serial schedule, all the transactions have a serial execution. In concurrent schedule, all the transactions have interleaved or you can say alternate execution. Now there were some advantages as well as disadvantages for serial as well as concurrent schedule. Now coming to serial schedule, the advantage was it follows the acid properties, so the consistency was maintained here. The disadvantages was there was very low throughput, like the number of transactions completing per unit time were very low. The wait time was very high, and coming to resource utilization, that was also very low. Now in concurrent schedule, the advantages was the throughput was very high, like number of transaction completing per unit time. The wait time was very low, the resource utilization was very high, but the consistency was low or the consistency wasn't maintained. So because of multiple advantages, we use concurrent schedule everywhere. But there was one disadvantage, that was consistency. So it was not following the ACID properties. Because of this consistency, we introduce serializability and some concurrency control mechanism, which makes sure that even if the schedule is concurrent, it follows a serial execution. So serializability ensures that the concurrent transaction yield results that are consistent with some serial execution, that is the final state of the database after executing a set of transactions concurrently should be the same if the transaction had been executed one after another in some order. So serializability makes sure that if there is any concurrent schedule and if we are serializing that particular schedule, so S dash would be having a serial execution. So even if S dash is formed from a concurrent schedule, we make sure that S dash follows a serial execution so that the consistency is maintained. Now in case of concurrent schedule, consistency issue may arise because of non-serial execution, because of which we use the serializability concept. Now coming to serial schedule, we don't need to use serializability because the execution is already serial. Now in serializability, there are two types of serializability. First is conflict serializability and second is view serializability. So how do we know that this particular concurrent schedule is serializable or not? So first we need to check for conflict serializability followed by view. So in conflict serializability, we check that if there is any cycle which is detected in a conflict graph. If a cycle is detected, we go to the view serializability and we check that if the view equivalent follows some condition. If it is followed, we say it is serializable. If it is not followed, we say it's not serializable. If the cycle is detected, we go to the view serializability. If the cycle is not detected, we say that this particular schedule is serializable. So we first need to check for conflict serializability. If no cycle is formed, we can say that that particular schedule is a serializable schedule or that particular schedule is a conflict serializable schedule. If the cycle is detected, we need to check for view serializability, and if in the view serializability also some conflicts arises or if the condition is not met, we can say that that particular schedule can never be serializable or can never have a serial execution. Now how do we form the conflict graph? So conflict graph is basically formed on the basis of nodes as well as edges. So how we form the graph? In the conflict graph, the nodes is represented as the transactions in the schedule and edges is represented as conflicts in the schedule, and we need to detect if the graph has a cycle or not. Now in a serial schedule, we don't need to form the conflict graph because there are no conflicts. If you see here, all the execution of transaction 1 is getting completed, only then transaction 2 is starting. So there will be no edges because edges represent the conflicts. But here if you see, there are no conflicts. So we can say that there won't be any conflict graph for a serial schedule. Now coming to the concurrent schedule, so here there are two transactions T1 and T2. So we need to represent it using the node. So it is T1 and T2. Now coming to the execution. So here if you see, it starts with T1, then there is a context switch, then there are some execution in T2, then again there is a context switch, and then again there is a execution in T1. So if we need to draw the conflict graph for this, we can see that there are two edges and there is a cycle which is detected in this particular graph. So T1 goes to T2 and then again T2 goes to T1. So there is a loop or you can say cycle which is detected in this particular graph. So concurrent schedule does not always have a cycle. So it's not always possible that a concurrent schedule will be having a cycle. It can have a cycle, it can't have a cycle. If it has got a cycle, we need to see for the view serializability. If it doesn't have a cycle, we can say that it is conflict serializable, because of which it is serializable. So a concurrent schedule can be conflict serializable, meaning that it is equivalent to some serial schedule of transaction and its conflict graph does not have any cycles. So if there are no cycles, we can say it is conflict serializable, that is, it is serializable. If there is any graph, we need to check for the view serializability. Now, since a cycle is detected, we need to serialize them. So we use the serializability here. First, we use the conflict serializability to detect the cycle using the conflict graph, and then we use the view serializability to check if the schedule is serializable after a cycle has been detected. So in this way, we use the serializability concept. Now, why do we need to serialize them? So to avoid the consistency issue which may arise because of non-serial execution. So in the non-serial execution, we can have some consistency issue and we don't want our transaction to be inconsistent, because of which we use the serializability concept. Apart from serializability, we also use some concurrency control mechanism, of which we will be talking in the next set of lectures. So coming to the types of serializability, there are two types of serializability, conflict and view. In conflict serializability, we check that if the conflict graph has any cycle or not. In view serializability, we check that if a view equivalent is following some conditions or not. So we'll be learning about all these as well in the next set of lectures. So this was all about this video. I hope you like this video. So if you like this video, please hit the like button. If you're someone who is new to my channel, can go ahead and watch out the tech content first. And if you find it useful, can go ahead and subscribe. Also, if you have not followed me on my social media handles, you can go ahead and follow. The links are in the description. Till then, take care, keep learning, keep growing, keep smiling. Bye all.